Now that we've done expressions, let's go on to equations. Okay? Now, notice at the top it says when solving equations, get the radical symbol alone first, and then do the inverse of it to both sides. So in doing so, the first step is going to be for 15 equals 9 plus the square root of x. Well, we have to do the inverse. We got to get that zero pair. We got to get the square root of x by itself. So since we have a positive 9, to make a zero pair, we take away 9 from both sides. 15 take away 9 is 6. It's going to equal the square root of x. Now we have to say, how do we get x by itself? It's not by itself. It has this radical symbol. Well, let's square both sides, because that's going to be what cancels out the radical symbol. We now have that 6 squared is 36, and so x is 36. If we were to check our answer, we want to know, is 9 plus the square root of 36 6? The square root of 36 is 6, and 9 plus 6 is 15, so it does work out. That's how you can check it. Taking a look at the second example, we have the square root of 3z plus 4, and that's going to equal 5. Our radical symbol is already by itself, so we have to do the opposite of it, and we got to square all of that. Well, the nice part, and we do it to both sides, the nice part about squaring a radical is that they cancel each other out. So we don't actually have to do like 3z times 3z. We just say, oh, it's the square root of 3z. When we multiply it by the square root of 3z, the radicals cancel out and we're left with 3z. Same with the plus and same with the 4. We then had to do 5 squared and get 25. Now we can solve our equation and say 0 pair, take away 4 from both sides, which gives us 3z is equal to 21. Now we can divide by 3 to get that z is equal to 7. When we check our answer, we're wanting to know if 3 times 7 plus 4, if we take the square root of that, does it equal 5? Well, 3 times 7 is 21 plus 4. So is the square root of 25 equal to 5? Yes. So we know our answer is correct. Looking at the third one, the square root of y minus 8, then added to 5, is going to equal 7. So first, to get the radical symbol all by itself, we take away 5 from both sides. So the square root of y minus 8 is going to equal 2. Reason it equals 2 is because we made that 0 pair with the 5 and took away 5 from both sides. To get rid of the radical, we square both sides. And we have y minus 8 is equal to 4. Remember that the exponent 2 and the radical sign cancel each other out. So y minus 8, the square root of y minus 8 squared is just going to be y minus 8. And then we do it to both sides and get 2 squared, which is 4. We then add 8 to both sides, because we need to make our 0 pair, and we're left with y is equal to 12. When we check our answer, what we're wanting to know is the square root of 12 minus 8 added to 5 equal to 7? Well, 12 minus 8 is going to be 4. So is the square root of 4 plus 5 equal to 7? Square root of 4 is 2. 2 plus 5 does equal 7, so it does work. Now let's do the opposite, where x has the exponent 2, and so we're going to have to cancel that. Looking at 49 is x squared. To cancel out that exponent 2, we take the square root of both sides to get that x is equal to 7. The reason that x is equal to 7 because we're saying that 49 is equal to 7 squared. We know this to be true. Now, let's take a look at the next example. We know we have to get x squared by itself, so we're going to add 7 to both sides because we're making that 0 pair. Since we're subtracting 7, we have to make a 0 pair by adding 7. We get that x squared is equal to 289 because we added 7 to both sides, since that's what the 0 pair was. Then we have to take the square root of both sides to cancel out that exponent of 2, and we're left with x is equal to 17. We know this to be true because what we're saying is that 17 squared take away 7, does it equal 282? Well, 17 squared is 289, and 289 minus 7 does equal 282, so we have the correct answer. That is how you solve equations with a radical sign.